Lesson 9-6b by Sarah and Leanne. So for theorem 9-4, it's called the isometry classification theorem, and basically it says that there are only 4 isometries. So the 4 isometries include translation, rotation, reflection, and glide reflection. As you can see, in translation and rotation, the orientations are the same. So you can see the letter R, it's not being flipped over, but what happens is the letters are being moved according to either the rotation or the translation. But for reflection and glide reflection, the orientations are opposite. So as you can see, the letters, the way it's portrayed is it's flipped into a different style, as you can see over here. So classifying isometries. So firstly, you suppose that the figure at the right is the pre-image. So this figure over here is the pre-image. And after that, so for example, for this question, the question is, are the orientations of the pre-image and the image the same or opposite? And what type of isometry maps the pre-image to the image? So firstly, how you check is that the orientations are opposite, and you know because this image is not a simple reflection of the pre-image. The isometry that leads to opposite orientation is not a reflection, but it is a glide reflection. So like the figure here, right, the way it's reflected is that the whole word is entirely flipped in comparison to the image in the previous slide, and this kind of thing is called a glide reflection. So now so how you figure out if the figure is an isometric image or not? Each figure is an isometry image of the figure at the right. Are the orientations of the pre-image and image the same or opposite? So if you're looking here, right, we're asking what type of isometry maps the pre-image to the image. So the figure is over here, as you can see. So the orientations are the same, and the image is not a translation of the pre-image because of the way the thing rotated. And the isometry that leads to the same orientation but isn't a translation is called a rotation. And a rotation is when the figure goes around either in a clockwise or anti-clockwise way according to the number of degrees per image. Okay, so a practice problem. So here, the thing is saying each figure is an isometry image of the figure at the right. So A, B, and C is possible problems or solutions.
Okay.
So as you can see here, each figure is an isometry image of the figure at the right, which is it's on the left. Are the orientations of the pre-image and image the same or opposite? And what type of isometry maps the pre-image to the image? So as you can see, there are 3 examples here that could be possible examples for the question on the left. Okay, so the first one A is a possible what?
Mr. Jeremy, sorry, could you edit back to the place where we first start this slide? Thank you. So this is an example. So let's say that the image at the left is the pre-image, and the 2 images A and B at the right are the images of the pre-image. So what we're trying to solve is what type of isometry maps the pre-image, the pre-image to the image. Okay. And yeah.
Okay, so as you can see, in this example over here, right, the figure on the left, the P over here, is the original figure, and this over here, A, is the one example. So firstly, what you can see is that the orientation of the pre-image and image are the same because they're both going in the clockwise direction. You can see that A is being rotated in a clockwise direction, and the type of isometry that maps the pre-image, which is the figure on the left, to the image is called rotation. It's called rotation because the letter itself is not being rotated, it's not being flipped, but then it's only being moved in a clockwise direction. So the second example over here is that the orientation of the pre-image and image are the same, because they're both going in the clockwise direction. And this is called a translation because, as you can tell, the letter is not being flipped in a vertical, horizontal, or what way, but it's basically just being rotated. And as you can see, this could either be a 0-degree rotation or a 360-degree rotation, as it is the same style as the figure on the left.
So for the first demonstration, this is a reflection. So basically, the triangle here is being reflected by the line of reflection, and this is the reflection of the first image, the pre-image. Basically, a way you can tell if it's reflections or not, like the distance from from a point of a triangle to the line of reflection should be the same. So measure this distance here. The amount, or like the length, is the same, and that should go for this part, this half, this half, this half, and this half. So basically, a way you can tell if it's a reflection is if the length from a point of the triangle to the length of the reflection is congruent. So this is how you reflect a triangle, as you can see by the line. If you move the line of reflection, the triangle gets reflected along with it. Another way is if you measure the distance from the point of the triangle to the point in the line of reflection, the distance between A and D and A prime and D should be the same. So as you can see, it's congruent. The next isometry is the translation. So first, I reflected the triangle over the line of reflection. Then I reflected it one more time, and as you can see, it's like a translation, and it slides over. So in the third demonstration, if this was the triangle, I would first reflect it over this line. If this is the angle, then I would reflect it over the first line. But you wouldn't just stop there. You would have to reflect it one more time over the second line of the angle, mark the second line, and then reflect it one more time. And if I move the angle, the triangle moves along with it. That's how you get a rotation. So in the fourth and last isometry classification theorem, this is a glide reflection, and what I already did was I already made one line of reflection, a parallel line to the line of reflection, and a perpendicular line. Reflect it, and then reflect it one more time, so that now it looks kind of like a translation. And then the marked perpendicular line, and you reflect it over the perpendicular. That way it's reflected, yet it also glides at the same time.